at this point, you should have done number 42 from the homework assignment. What I'm looking for in this particular question is that you understand what's happening in this whole slope process. They're taking a point, and let's just say this is 1, 1. And we're basically finding the slope of different points, and we're getting very, very close. And the idea is, and I know it's hard to see, but the idea is that we're getting very, very close so that we can actually figure out what the slope is at this point. I'm being very exaggerated in my tangent line. It should be closer to that curve, but I think you get the idea. That basically the line in which it touches. And the point is, what we're trying to do is find the instantaneous rate of change, or rather the slope of the tangent line, or the speed. If we were talking about speed, you know, versus the average speed over the course of a trip versus what is your speed at that moment. If you were to take a trip, let's say from here to Syracuse, and you averaged 50 miles an hour, that does not mean that every single moment of that trip you were traveling 50 miles an hour, does it? At some point, you probably were traveling 50 miles an hour, but there might be times where you were down as low as 20. There may be times where you were stopped. There may be times where you're actually going 70 or 80 miles an hour. The point being that if we want to find out what your slope is, or in our illustration, your speed is at one instant, then what we're basically doing is we are finding points in time, or rather slopes, and getting closer and closer to that point. In essence, what's happening when a radar gun is coming at you is it's basically figuring out what the speed is amongst time, like time, right? Travel, time and travel, and it's doing it in a very fast rate, obviously. But that's initially how it started. So if I want to find the slope of a tangent line, there are two methods in doing so. One uses the limit as h approaches 0, and the other one uses the limit as x approaches the number. Now, what do they mean? The h approaches 0, h is representing the distance between or rather the distance away from, in this case, 1. Okay? The distance away from 1. So as that distance shrinks to 0, we're approaching 1, and the idea is that that distance away from it is getting smaller and smaller. This version is basically saying, hey, I'm going to pick values very close to 1. Now, they might seem like, hey, they're the same question. They're really just, right, they're two different perspectives. And how we actually solve them is a little different. So agree that this question here is y equals x squared, and I think you can gather that. So how does that look? Well, let me show you. So if we're to do the h method, okay, well, hopefully I did these separately, and I did. If we're to do the h method, basically what you would do then is we're going to take 1 plus h and plug it into the equation, which of course is x squared. And then I'm going to plug in 1 all over h. And yes, I am going to do the limit. I'll get to that in a second. But so 1 plus h squared, hopefully we can all do this mentally, but I'm going to just multiply that out for us. And you see that, okay, 1's subtract, and then we can divide the h in there, and I'm left with 2 plus h. And I'm going to do this as the limit as h approaches 0. So what does that mean? Plug in 0 for h. So 2 plus 0, I get the answer is 2. Easy enough. Okay, so that means what I'm saying is that the slope at the point 1, 1, that slope is, in fact, 1. All right, well, let's look at this alternative method of doing this. Let me just erase this so I have some space. Move this guy up here. All right, so how does this approach? Well, what's f of x? F of x is x squared minus f of 1. That would be 1 squared over x minus 1. Again, I'm doing this the limit. X approaches 1, so now let's keep going. Notice that the top can factor into x plus 1 and x minus 1. And of course, the denominator is x minus 1. The x minus 1's divide out. So what I'm left with is the limit as x approaches 1 of x plus 1. So now we plug in that 1 plus 1. Voila. And you'll notice these answers are the same, and they should be, but the approach is different. In essence, really, when you're looking at the two methods, the H, I'll call it the H method, is more for those of you who are very good at multiplying or expanding, the binomial theorem kind of people. The one here on the right are for those of you that can factor well and divide, because there will be some in which you can't factor right away, but you'll have to be able to divide. And so if you're good at division, then that's it. If you're good at multiplication, then you stick to the H method. Either way, you'll get the point, you'll get the same thing. All right, so let's do another example. Find the slope of the tangent line to y equals x squared at 3, 9. So I'm going to do it both methods so you can see this, okay? The first one is the limit as h approaches 0. All right, and how this works looks like this. F of, all right, 3 plus h minus f of 3 over h. So I'm going to plug that in. That means I'm going to do the limit, h approaches 0, and I'm going to plug in 3 plus h into that equation. So that would be 3 plus h squared minus, you guessed it, 3 squared over h. So multiplying it out, it would be 9 plus 6h plus h squared minus 9 over h. Again, that's the limit as h approaches 0. And so the 9's subtract, and I divide that, so I get 6 plus h, and I'm going to plug 0 in, and I get 6 as my answer. Alternative method, of course, is using the x, which is the limit as x approaches 3 of f of x minus f of 3 over x minus 3. Well, f of x is x squared, right? Minus 3 squared, which is 9 over x minus 3. Again, this factors into x plus 3 and x minus 3. The x minus 3's divide, and I'm left with x plus 3. So it's the limit as x approaches 3 of x plus 3, which makes that 3 plus 3 over 6, which of course is the same. All right. What about this? What if I said instantaneous rate of change? Well, the truth is it's exactly the same thing. It's another set of wording for you. In fact, instantaneous rate of change, slope of a tangent line are both one and the same. Just like we learned with slope of a secant line and average rate of change. That distinction is quite important. And as we basically are reviewing from here to the end of the chapter, that's something that you need to be, very keyed in on, is the vocabulary. Instantaneous and slope of a tangent, average and slope of a secant. Okay, so how do we do this question? This says let f of x equal this lovely equation. Find limit as h approaches 0 of f of negative 2 plus h of minus, f of negative 2. What is it basically asking? It wants to know what's going on at negative 2. Okay, and so what I'm going to do, just like I did with all the rest of them, is I am going to find the limit as h approaches 0, and I'm going to plug this into my equation. So it would look like this, negative 2 plus h squared plus 3 times negative 2 plus h minus 4, that's just the negative 2 plus h part, minus f of negative 2. So if I plug in f of negative 2, that would be minus a negative 2 squared, and I didn't put the negative in front of that, that'll mess me up later, so plus 3 times the negative 2 minus 4. All of this, when it's all said and done, I'm going to divide by h. As I told you, this is for those of you who really like to multiply. So the limit, h approaches 0. All right, negative 2 plus h, right? So that would be a negative on the outside because of this negative here, or this, whichever one you're referring to. That would give me 4. That would give me minus 4h plus h squared minus 6 plus 3h minus 4. I'm just going to keep on going, minus. And then inside this whole thing, I would have negative 4 minus 6 minus 4 all over h. Now we just got to keep simplifying, right? So here I've got negative 4 plus 4h minus h squared minus 6 plus 3h minus 4. I'm going to distribute this negative plus, and I guess the way I'm going to look at this is negative 14. Is everybody all right with that? But that's negative 14. So I'm actually just going to write positive 14. And this will all be divided by h. Combine like terms. I got negative 4, negative 6, and negative 4 plus 14. In other words, all the constants cancel out. And I'm just going to tell you with the h method, that should happen every single time. So I have 7h minus h squared. I'm going to divide by h, which gives me 7 minus h. I'm going to plug in 0, so that means it's 7. All right, let's see it this method. As I said to you before, right? I should expect to get 7, but how does this differ? Well, I need the equation, so sorry, I'm going to have to scroll this back up here. So f of x, so this is the limit as x approaches negative 2. Of course, same question, right? But it's a different method. So we're going to do negative x squared plus 3x minus 4. And I'm going to plug in negative 2. But I know for the previous question, so I'm going to cheat a little bit, that it's 14. And it's going to become plus because it's a negative and a negative. And then I have x plus 2 in the bottom. So I have negative x squared plus 3x, right? Plus 10. And I'm going to have to factor this. Remember, you've got that negative in front. Some of you may have to factor out that negative. I'm not sure if that's, you know, something that you have to do or how that's going to work for all of you. But you know whether you can factor or not. So this would be like this: x minus 5 and x plus 2. And we'd have, of course, that x plus 2 would divide out. And so I would plug in negative 2. So I'd have negative, and then I have negative 2 minus 5. So I'd have minus, and then a negative 7, which, of course, is positive 7. A little bit way of going around it. So there you go. What about this? What if I ask the question, the instantaneous rate of change of f at x equals negative 2? Well, we just solved that. That's exactly what see, I could ask the same question. This is 3 different ways to ask the same question. Limit as h approaches 0 with that f of negative 2 plus h, or the limit as x approaches negative 2, or simply say it like this: the instantaneous rate of change of f at, and in which case you can choose whichever method, but we already know the answer is 7 since you've already done it. How about this one? The slope of the tangent line drawn to the line y equals f of x at the point negative 2, negative 14. Guess what? That's exactly the same question as well. I just want to point out that there are 4 different ways to ask all the same thing, and you need to be able to interpret that to mean the same thing. It's going to be quite involved, and you'll notice that we have quite a bit of practice still left in our packets, and this is the last lesson of the unit. So hopefully you'll get that practice. If you need help, come see me.